morning, everyone. My name is Dusty Pierce, and this is Laura Harper. She's from the Cortez, Dolores area, and I'm from Pagosa Springs. So we're going to start with a little history that most people are not terribly aware of. So I'm going to start 200 million years ago. Okay, if the geologists are right, we had a supercontinent called Pangaea, and both North and South America broke away from Pangaea around 200 million years ago, and North America started drifting a little bit to the west and slightly north, and South America pretty much moved to the west. So this made North America very isolated from all the other continents. At around 50 million years ago, we see the beginnings of the horse, and this is known as the dawn horse, what the paleontologists generally believe to be the first of the horses, and it formed right here in North America. Now this is very important. To be a native species, okay, it has two requirements. The first requirement is the species has to form in its own ecosystem. Okay, the second requirement is it has to have formed without the hand of man. So the horse, 50 million years ago, evolved in its own ecosystem, and man showed up on this continent, 15,000 years ago, maybe up to 30,000 years ago. So definitely the horse is a native species to North America. So we see the involvement of the horse where through evolution, the horse changed its morphology. Okay, it went from a three-toed animal down to a solid-hooved quadruped. So in the process of this, we start seeing all kinds of archaeology and paleontology coming up with different species of early horses. So a lot of confusion in all of that. And one of the things we're going to show today is that these early species of horses are directly related to the modern horse. Okay, so Equus caballus is the modern horse that we have today. So when we look at the Yukon horse, it's an Equus caballus. When we look at the Equus scotti, it's an Equus caballus. When we look at the Equus mexicanus, it's a Equus caballus. All of these horses are descendants of the same horses we have right now. Now, somewhere at least 1 million years ago, okay, we had a land bridge formed between the North America and Asia. And the formation of this land bridge, we started to see the migration of animals. So the horse went the wrong way across the land bridge and ended up in Asia, Europe, and Africa. This places the horse on 4 of the 5 continents, and they evolved over there. Now, one of the interesting things that we've discovered with modern genetics that was kind of unknown was that the horses in Europe have the same genetics as the horses in North America. For this to happen, we have to have had the horses traveling back and forth across the land bridge over this very long period of time. So when the Ice Age formed, the ice sheets came down to about the Canadian border, and they came further south in the Rocky Mountains. Something that most people do not think about is the Ice Age also affected the southern hemisphere. So we saw the ice sheets coming north in South America. So around 5 million years ago, we saw North America and South America connect through a series of volcanoes that we call Central America. So not too long after that, we started seeing horses migrate all the way down into South America, putting the horse on 5 of the continents. So now the only continents that don't have horses is Australia and Antarctica. So this is the basis of the horses that we have. Now in this, it's a really fun thing to pay attention that these horses were equus caballus. So I have my expert on the genetics sitting beside me here, and she's going to take you into a little more detail about this.
Well, I guess it was about, I'll take you up to 2012. How about that? Let's go to 2012 when I entered into this rabbit hole of genetics and learning about the horses. And I was first introduced to this by Dusty Pierce and an individual named Bob Browning, and went out to the forest in the Jicarilla in New Mexico to find out a better way to round up the horses. I wanted to see how I could be an influence in making sure that they were being treated humanely. And in all of this, I ended up adopting my own Mustang. And his name is Rambo. And Rambo was a 3rd strike horse, and that means that he had gone through an adoption option 3 times. That makes him a sales authority horse and up for buyers that, maybe not will be a bad outcome for him, or certainly one that's not certain. So anyway, the first thing I set about doing was finding out his DNA. And so I sent his DNA from his tail. I pulled out 40 plugs out of his tail with the DNA at the end, and I sent that in to Texas A&M Dr. Gus Cothran. And I was fascinated by what I got in return. And I found that Rambo was a Galaseño #1 marker, and then #2 marker, he was a cream draft, and a #3 marker was a Welch pony. And so I thought that was intriguing. I called Dr. Cothran. I ended up making friends with him, and he explained to me that many of these Iberian horses are going to have the draft influence in them. And so anyway, Rambo came to me as an Iberian horse. And so then let's fast forward into 2024. So in that same forest that I adopted Rambo from, there's a great horse named, I named him Cabresto, and I had been following him since 2012. And when I was trying to arrange to make sure that he would always either be in the forest, but if he ever came to be a sales authority horse, then I would be able to rescue him. And so he'd been in there for 30 years, and beautiful horse, and he passed away. We couldn't find him. And the speculation was that he had a mare, and that's all he could probably fight for anymore, because he's becoming an old, he'd be like 90s, for a horse in the forest. And so anyway, he passed away, and I had a guide, and we went out in the snow, and we found him. And the Forest Service allowed me to collect his DNA. And so his DNA came back. He's 15 years difference between Rambo and him. They're in the same forest, but in different areas. Rambo's from the Caracas, Cabresto's from the Canyon. His DNA came back Guarano, Calaseño, the same as Rambo's, came back Belgian draft, and then came back Welch pony. So he was identical to Rambo, and I was just astonished by that. And so the result of that is I started questioning, why is Rambo a cream draft and Cabresto a Belgian draft? And so then I understood from Sarah Annan, that's an expert historian on genetics, shared with me that the cream draft was developed by breeders in Ohio in the 19th century. And where did they get the breed? From the Belgian draft. And so that was just so fascinating to me. And then the next step was, there was a study done by Dr. Gus Cothran of 40 horses and all their DNA. And those horses came from that same area that Rambo and Cabresto are from, and that is that alpine area of northern Italy, the Galicia, the Portugal area, bordering, all the other countries like France, Italy, Poland. And so all of those heavy horse mixtures plus the Iberian breeds are those horses of our herd of the Jicarilla. And so that was such fascinating information for me to find out. And so I'll give it over to Dusty for a moment, and then I can take you back then further than 2025 and 2012. I can take it back to where you began.
Okay, so I'm going to back up a little bit here. And we're talking about the Ice Age and the land bridge forming. And I mentioned that it had to be at least 1 million years ago, and they, through genetics, they now think it could have been more than that, maybe 2 million or more. But one of the things that happened when the Ice Age formed is the ocean levels dropped, so you could walk from Europe into the British Isles. So horses migrated into the British Isles. And we have horse bones in Britain that are 700,000 years old. So those horses ultimately came from North America across the land bridge and all the way to the British Isles. When the ice sheets started receding, then these horses are landlocked on the British Isles and developed there. So some of these horses that came out of that would be the Welsh pony. So this is kind of an unusual tie, but it's something, we hear a lot about the Bering Land Bridge. You never hear much about the English Land Bridge. So this is part of the research in trying to understand the migration of all these horses and how they got back and forth in the continents. So when we come forward in time and we start seeing the horses developing in North America, they were literally everywhere. We find huge numbers of horse fossils in Florida. We find huge numbers of horse fossils in South America. We find huge numbers of horse fossils in Mexico and Central America, all over Canada, all over the United States, from the West Coast to the East Coast. So this is, one of the things that started a lot of this research for me was being a cowboy. A horse can easily travel 20 miles for a drink of water, out on the range. And we have herds, wild herds, that their water source is actually 20 miles from their grazing source. So every day those horses travel 40 miles. So in the process of that. So to me, these ice sheets forming up in the northern latitudes developed very slowly. So it was common sense to me that the horses would migrate south, and there was plenty of grass for them. So it didn't make any sense to me that these horses could have gone extinct during the last ice age. So this is where we started challenging, this particular thinking. And in the process of challenges this, we come up with all kinds of interesting information. Now, I'm going to not get ahead of myself here too much, but I'm going to come back to this in just a few minutes. So, but we have a lot of very fun stuff for you.
So I'll take it from there. So I left us off in Spain, in Portugal, and in those alpine areas. And the time is before Spain, after Spain was invaded by the Moors. And so if you take our current horses, and I left you off with the Garano, the Belgian Draft, the Conic Polish horse, and the Italian Lusitanos, we have to then go even further backwards. And so about the time of 711, or this year 711, the Spanish, the area was in Iberia at that time, Andalusia. Anyway, it was invaded by the Moors. And so the horses that they were riding were the cavalry horses that were made up of the Berber from northern Africa, the Spanish Barb, and the Turkoman. And so those horses then came into the area that's now Spain, and over 800 years developed into the horses that they are today in 1492, that came over then to the West Indies, to the Central and South America, up into North America. And so that was the return. But I'll now fast forward backwards. So now you're going to go from the alpine areas of those countries, but now we're going to go even further back to Mongolia, 6,000 years ago. And so that is when they first figure out that the horses were then domesticated. And they determined that by bitware and those artifacts. But even before then, the horses were being domesticated because they were being used for milk and they were used for food and in those Mongolia areas. And then the horses even go then further back into Russia, through Eurasia, and back to the Bering Straits. So it's...
yeah, this is very interesting that they have the oldest domesticated horses at around 6,000 years. But older than that, they have human teeth, and they find the calcium in the human's teeth source is horse milk. Meaning that these people either were milking Mustangs, which is unlikely, or they had domesticated the horse for its milk and other things earlier age. So I think there's no doubt that we're going to find that the domestication of the horse goes back much further than 6,000 years. Now, some of the oldest cave paintings in the world exist in places like Spain and France, and we have paintings that go back that are anywhere from about 20,000 to maybe 40,000 years in age. And the most common animal in these paintings are horses. Okay, one of the interesting things, a lot of these horses are spotted horses. So this, you would think leopard Appaloosa when you see a horse with spots all over its body. So another tie to this goes back to the Lipizzan horse, which when you look at the structure of the neck and the head, they have a very distinct neck and head. And when you look at some of these cave paintings, you see that very distinct neck and head. So they believe that this ties the Lipizzans and the horses that are coming out of Spain and Portugal directly to, these breeds of horses. Okay, a little sidelight to this. When they were studying some of these early cave paintings, they came across some artifacts of the horses with human tack. And this tack predates domestication of horses at 6,000 years. So this is something that needs to be studied a little more because, again, this is probably going to be taking the domestication of the horse back further than what science generally accepts today. So, in the 1500s, we had the Spanish bringing horses to North America. It started with the second voyage of Columbus, and he brought horses over to Espanola, the island, and eventually some of those horses were moved to the mainland. And the Spanish, when they first came here, they brought war horses, okay? The Spanish conquistadors rode stallions. They didn't ride mares. And the stallions had to be solid colored. They didn't ride any colored horses. That was beneath a conquistador to have a colored horse. So the first horses brought over were almost exclusively stallions. So this makes the breeding impossible without the mares, unless there were already mares here. So over time, they started bringing more horses across, and they started bringing mares across to be able to breed horses in the New World. So in the process of the development of the horse in the New World, we start seeing horses being tracked. Now, one of the things you find in history is they will tell you that the Spanish never lost a horse. They tracked them and they had to document every death of every horse, and that they were never stolen by the Indians and all of that. And this is something you read in history books. Simply not true. Now, the biggest movement of the Spanish horse that history acknowledges was the Pueblo Revolt of 1690. So the Pueblo Indians simultaneously attacked every Spanish settlement in the state of New Mexico, or Nuevo Mexico is what they called it at the time, and they kicked the Spanish out of the state of New Mexico for almost 20 years. Okay, in the process, they captured at least 1,200 head of horses. So, by the way, the most successful Indian battle ever fought against the white man, Pueblo Revolt of 1680-90. So, little piece of history most people don't necessarily know a lot about. But 40 years before that, we have the then governor of Nuevo Mexico tell this very interesting story in the Spanish archives. The mounted soldiers of the Spanish had a cavalry battle with the Ute Indians. They were fighting mounted Ute warriors in 1640, actually 1639 is when this battle took place. The Spanish won the battle because of superior weapons, and they were able to capture quite a few of the Ute warriors and some of the Ute horses. So, Spanish, what did they do with Indians? They enslaved them. Well, these Utes were already horsemen, so what did the Spanish do with these enslaved Utes? They put them in charge of their horses. So, a few years later, these Utes escaped, stealing over 200 head of Spanish horses. So this is just another example where the history leaves this little story out, but this is putting horses into the American West in the hands of the Indians quite a bit before what they normally acknowledge. So now we have paleontology has been digging up horse bones for over 100 years all across North America. And they assign names to these horse bones. A lot of times when they dig up a horse, it gets the last name of whoever's digging them up. So Scotty invented the Equus Scotty. Okay, so anyway, that's the way a lot of these horses got named. And you will see names like the stilt-legged horse. You want to read off a few of them?
Well, you can go ahead.
Well, all of these ancient horses that they're digging up turned out to be Equus caballus. All of these horses are perfectly capable of breeding directly to the modern horse. So these horses were not these 50 different species of horses. These were all horses that some of them were tall and some of them were short and some of them were heavy boned and some were light boned, much like the light boned Arabian of today or the light boned thoroughbred of today and the heavy boned draft horse. Some of them were tall, some of them were short like the ponies. So we see the same diversity of these horses at this particular time period. So modern paleontology, I have to say this, you don't get your PhD proving your professor wrong. You get your PhD by parroting your professor. So in the process of this, we have a new generation of paleontologists studying now. And some of these new generation paleontologists are Native American. The Native Americans were raised with oral histories of them always having the horse. So they have a complete different mindset. So now these people are starting to take a look at some of the bones that are in the museums. And guess what they're finding? They are finding that some of these horse bones are much earlier than Columbus, but a long ways after the Ice Age extinction that's been taught by the earlier professors. There were no horses in North America after 12,000 years ago. So, in recent years, we have discovered a lot of horse fossils, including frozen horses with intact skin, stomach contents. We have a foal found in Siberia with liquid blood. I mean, wonderful, wonderful collagen for doing the DNA studies on all of these animals. So in the process of all of this, they're taking a look and they find horses that are now only 6,000 years old. So the horse had to have survived for another 6,000 years from the extinction. By the way, they also found mammoth with these horses. So that means that the American mammoth survived at least 6,000 years longer than what they traditionally teach. So in the process of this, I started looking for information, and we have come up with probably somewhere between 50 and 200 sets of horse bones that date between 10,000 years ago and the 1500s, so pre-Spanish, and this period of time is called the Holocene in geology, and we have all of these horse bones that have been found in the Holocene epoch that is now causing them to start rethinking. So one story I will tell is one that's near and dear to Laura and I, and this is Navajo Lake, and it's right on the border of southern Colorado and northern New Mexico. And before they could flood Navajo Lake, they had to do an archaeological survey. Now this area is known for its Anasazi ruins and all the way back into the basket makers forward, and in fact some even back into the archaic Indian period. And in this study, right at the confluence of the Piedra River and the San Juan River on the upper end of Navajo Lake in Colorado, okay, they were excavating two major ruins. So in an archaeological dig, as they're digging down through it, they have what they call context. They use the pottery to help identify the age of these ruins and many other things. But in context, they were down to a depth where they were at the year 1100, so 400 years before Columbus. So they come across a horse bone, okay, then another one in Anasazi ruins. Now this is impossible, according to the paleontologists. So their first thought was that we had some rancher with a bad sense of humor step into the ruins and bury a horse, okay? But they didn't see any signs of the context of the dig being disturbed on their way down to where they found the horse bones. So that forced them to do C14 testing to see how old these horse bones were. And guess what? The horse bones came back to the year 1100. Okay, so this is one of the many examples of a horse that has survived from the Ice Age to just 400 years before the Spanish brought horses to America. So in doing this, I have to explain something. This horse didn't drop out of the air, okay? So a generation for a horse is generally considered to be about 5 years. So we're talking from the extinction event 10,000 years ago, roughly round numbers, pardon me, 10,000 years. So that is 2,000 generations of horses. Okay, so I'm going to go the other direction now to explain to you the numbers in this. So you have one horse. It had 2 parents, 1 generation. Second generation, there's 4 horses involved, okay? When you go to 3 generations, 8 horses. In 10 generations, there's over 1,000 horses in the pedigree. But in just 20 generations, there's over 1 million horses in a pedigree. So we have a 2,000-year reign of horses. So there had to be very large numbers of horses that survived the Ice Age to get to this time period of 1100. So down in Mexico, they dug up a water hole, and pardon me here. Can I have a drink here?
Yes, and I can give you some relief whenever you're ready.
Well, go ahead.
Okay, so let's talk about, the ancient and the diverse fauna during the middle and the many ice ages that he was referring to. And so I'll take you then. I wasn't quite ready for the stilted horse, and then you can pick back up. But when we talk about that, we're talking about these ancient breeds, like the Harrington Hippus or the E. conversidens. It was a old horse bones in Mexico, or the Yukon horse in Alaska, or the E. lambi, or the Equus caballus, which we say is about 1.5 million years ago. But my point here is going to go into a little bit more into the genetics, because the genetics is the building blocks of these horses. And the genetics and the occurrence of their mutations start to help you understand that there's not a lot of difference between Equus caballus and the horses that we know today. And so I'm going to go a little bit into the genetics of that, and then you can pick up back into your numbers. But saying that genetics is the building blocks, let's talk a little bit about chromosomes. And so your chromosomes is your building blocks, but your genetics are those that attach to your chromosomes, that changes and variations. And so I want to share with you that there's the horse that we consider wild, and that's the Przewalski. And the Przewalski, as you remember, is out of the Mongolian area and that parts of Eurasia. And so the Przewalski is going to have 66 chromosomes, whereby your Equus caballus is going to have 64. But the interesting thing about this is that the Equus caballus and a Przewalski, they can interbreed, and you can have a result of a fertile mare. Now, if the chromosomes are 65 chromosomes, then you're not going to have a fertile mare. If the chromosomes are 66, you will have a fertile mare. And so all of that is very interesting. And so to give you even a further break, I want to talk a little bit more about how all of that comes into understanding why there's evidence that the horses originated in North America and they habituated back into North America. They were already here in North America. And if you look at other species, and let's take, for instance, the suckerfish. And we know how protected they are, and that's important. But there's 79 variations of the suckerfish. Or you can look at the sage grouse. And how many variations of the sage grouse are there? Well, I know of 3 I can just, come out with is the greater sage grouse or the Gunnison sage grouse, but these are also protected. And so understanding about the ancient breeds, your Przewalski that's in Mongolia, and your bones that he's speaking about, the stilted horse bones and that whatnot, those are still Equus caballus. And so I'd like to introduce to you a horse that's my favorite, and I say that he is a horse, of course, and that horse is Bamboo Harvester. Have you ever heard of that? Have you ever heard of Mr. Ed? That's Bamboo Harvester. So he's talking about if you put your name, if you find a horse, and that's a horse, you get to put your name on it. I'd like to put my name on Mr. Ed and claim that Mr. Ed is in the same as Equus caballus, because he has 66 chromosomes, and even if he talks, he is a horse, of course. There's some humor for you. So that'll take you now back to the numbers that you were speaking about.
So we have this point that in order for horses to be found in modern times, there had to be a huge number of horses to get to this point in time. And as it turns out museums have huge number of horse bones, but very few of them have been carbon-14 dated. So we're hoping to see a lot more of the young people starting to go back into the archives of the museums and take a second look. And we have this going on at the University of Colorado and the University of New Mexico right now. And both of them have taken back horses belonging to the Native Americans quite a bit further than what they generally credit the Native Americans for having horses, because they are finding this evidence. So we're kind of in the early beginning stages of this. Down in Mexico, there's a water hole down there, and bones were spotted at the water hole, and somebody brought it to the attention of some paleontologists, and they started a dig there. And they come up with mammoth bones and horse bones and a few others. And anyway, so this led to a major, excavation of this. So one of the interesting things in this excavation is they had these horses from the Ice Age, but they kept getting younger horse bones and younger horse bones and younger horse bones all the way up to the 1500s and after. Okay, so there appears to have been live horses here before the Spanish arrived and after the Spanish arrived. So that's just one site. We have quite a few sites down in South America now. So as a general rule of thumb, you don't hear much talk about what's going on in paleontology in South America, but they are now starting to study all these horse bones they're finding down there, and the same thing, they're starting to find out that these horses had survived beyond the Ice Age. So this is very, very important to us. So it brings us to the point that the horses are native. This means that the BLM Forest Service has to change the way they treat the Mustangs, because they are in fact a native animal. Okay, we hope for the betterment of the Mustangs that this will be a good thing for them. Okay, we are finding that we have isolated bands of Mustangs right here in North America, and an example is our Caracas Mesa herd that Rambo came from, that is genetically pure enough to be considered its own breed. And Dr. Cochran from the University of Texas is the one that did the research on this and helped us to understand these things. So this is very fun, because we're seeing these isolated bands of horses being looked at across the United States, and we're starting to see that, hey, these are very special. So.
And going along with that, and going along with the science, I always go to the chromosomes, I guess. And so it's like new things get discovered and then discovered again. So in 1959, they discovered the Y chromosome for the horses. And so they really didn't know what to do with that Y chromosome. And then what resulted in that is that now they can use, now let's fast forward from 1959, that's 66 years later, they now have determined that they can use the Y chromosome to reconstruct the last 1,500 years of genetic history of horses and the stallions. And so that is incredible. And so that tells you that if you look at the Jicarilla horses and why they're so important in their heirloom museums, is what more can we find out from them with science. And with that, how sometimes misinformation gets out there and how easy it is. There is this story, I don't know if you've heard about the story of the Caspian. It's probably the oldest horse I consider it probably the most ancient horse of Iran. And anyway, back in, I don't know, they go back 3,000 years BC. That's how old those horses are. So they were thought to be extinct 1,300 years, that they all went extinct. There was no more Caspians until all of a sudden, lo and behold, in 1965, we find a Caspian horse. And they're not extinct. They're an old, beautiful horse, but they're not extinct. But for a long time, that rumor was going around, so you can see easily how things can be manipulated to kind of change a little bit of what reality is. So we know for sure we've got suckerfish, that's their 79 species. We've got sage grouse, I've named 2. And we have the variations of the horse. I hope that we have proven that Equus caballus, having 66 chromosomes, but can still mate with a Przewalski and come out with a fertile mare. So I think in the long run that we can conclude that a horse is a horse, of course. I don't know if anything you would like to add to that.
Okay. A couple of kind of interesting things. The zebra can breed to a modern horse. Okay. We see that with burros, even though they have different numbers of chromosomes, they can breed to a modern horse. So these horses are much more adaptable than they sometimes are given credit for. And one of the very interesting things in most of the Mustang herds is we don't see genetic problems with close breeding. So one of the things, when I was a young man and I first heard the term close breeding and inbreeding, I didn't really understand the difference between them. So I asked my father, what's the difference between close breeding and inbreeding? And he says, if it works, it's close breeding. If it doesn't work, it's inbreeding. And that's how he defined it for me. So we see it with cattle all the time, where you have a bull that is breeding, its own children and grandchildren and stuff like that. And that's why you need to rotate bulls in, a cattle herd. But with these Mustang herds, it's funny how naturally you very rarely see any problems with these Mustang herds, particularly if we can keep the numbers of the herds up high enough. So with all of the domesticated breeds of horses, we are starting to see more and more problems with the genetics, because if there's a genetic flaw in a stallion, this is getting bred into multiple mares. And we're starting to see a lot more problems with that, with people trying to breed pure quarter horses or pure thoroughbreds or pure anything else. And it's kind of surprising how little we actually see this in the Mustang herds. And when we first started looking into the DNA of the Caracas Mesa herd, we really expected to find a lot of the modern horses in there, because all of the ranchers talked about, turning out horses into the wild horse herds. But that's not what the genetics showed in this particular herd of horses. These horses are the purest of the actual Spanish horse that may exist in the United States. So somehow they have survived surprisingly intact with this. So we have other isolated herds that are that way. I've noticed that some of the herds around the Grand Junction area here, we see isolation, but it's a little different type of isolation from it. And some of them we see a lot of what I would call more modern horse genetics showing up in them. But it's really fun to get in here and look at all of this and change what we think we know about the horses. But we now know that the horse is a native species, particularly to North America, and that it migrated into South America, Europe, Asia, and Africa, and all of its forms. So this is kind of exciting news for us, but it's going to cause a shift in the way horses are managed, because with the horse becoming a native species, it changes the way they have to be looked at and treated by BLM and Forest Service on their management of these horses. And we hope that this will be a change for the better. So, questions?
I'll take us, before we go into questions, I'll take us just roundabout and bring us back to Rambo so that we can conclude there. So when I go back to Rambo, I want to make that final, is that in New Mexico, we have, we believe we have the closest to the original square horse possible. When I say square horse, I mean that this horse has the dimensions of 14 hands tall, 14 hands across on both sides. And the significance is that the original horses that fit the conquistador armor would be the square horse. And Rambo came out, I said Galiseño, but when I really looked at that breed, his muzzle is a little bit kind of slender, but his eyes are wide apart. And so there's some significance there. And that means that the square horse had eyes that were further apart because it fits the male of the conquistador, plus the distance between its two ears. And so I thought that was very significant. And if you would just touch upon that briefly about the museum findings, then I'll conclude for us.
We work with a young lady by the name of Sarah Annan. She does a lot of posting and has invaluable knowledge about the horses. And she's been breeding the Spanish Mustangs here in New Mexico for many, many years. And she has really accumulated a lot of knowledge about this whole square horse thing. So somebody a few years back donated actual Spanish armor, conquistador armor, to the museum in Albuquerque. And they donated armor for the dogs, and they donated the armor for the horses, okay, and armor for the humans. So the museum wanted to put on this display, so they went and got a modern quarter horse, made out of plastic, and they went to put the armor on it for the display, and the armor didn't fit. So then they started trying to figure out what happened. And anyway, they ended up contacting Sarah Annan, and she started looking into this, and she determined that the armor fits these horses that we have in the Caracas Mesa area. So these are actual genetic Spanish horses. And we don't know if they came from the Spanish Revolt of 1580, when the Indians kicked the Spanish out of the state of New Mexico for 20 years and captured over 1,200 head of horses or not. But it's amazing that that horse herd up on Caracas has these very, very strong genetic traits. And we didn't see the quarter horse and the thoroughbred and the Arabian and all these things we were expecting to find when we started doing the genetics on these horses. So it's kind of fun for us because we have learned an awful lot about this whole Mustang genetics and how it's affected. So
in conclusion then, I would say the most important thing is to take home is that genetics, science, and history will tell you the truth. And when you talk about history, you have to talk about oral history. So when you look at all of these different stories, then you can come to a conclusion. So if there are any other questions, then we will conclude this time.
okay,
I
thank
don't
you.
really have a question, but a comment. I saw an article not too long ago about somebody found what they called, I think it was a tarpon horse in a slaughter pen. And they had thought that horse had gone extinct a long time ago, and then they managed to find out that they were not extinct again.
And what's interesting about the tarpon, it's got 14 chromosomes. So that's an interesting fact to take home with you. So yeah, thank you for sharing that about the tarpon. Any other questions?
Thank you.
Thank you. Thank you all.